Okay, this question, we have the equation of a hyperbola, y squared over 9 minus x squared over 16 equals 1. The general form for one like this would be y minus k squared over a squared minus x minus h squared over b squared equals 1. And you can see in this case, h and k are both 0. So the center of this is 0, 0. No surprise there. But now A and B define spans. So 9, of course, is 3 squared. Y squared over 3 squared minus x squared over 16 is 4 squared equals 1. So I like to say the span in Y is 3. So from the center, we go up 3, down 3. And the span in X is 4. From the center, we go over 4, over 4. Now our transverse axis, Y comes first. Y comes first, so the transverse axis is vertical. It is the y-axis in this case. And what is the equation of the y-axis? The equation of the y-axis is x equals 0. Now we'd like to find our vertices. So again, we said our center is 0, 0. Our span in y is 3, so we're going to go up 3 to get to a vertex. We'll have a vertex here, down 3 to get to a vertex. We'll have a vertex there. So our vertices are 0, 3 and 0, negative 3. Now the span in X is 4. That will help us define our asymptotes. So we go over 4, 1, 2, 3, 4, 1, 2, 3, 4, and we create a box. And the asymptotes go through the corner of the box. So you can see from the center, we go up 3 and we go over 4. The first asymptote here, up 3 over 4, continuing that direction would be y equals 3/4 x. Similarly, down 3 over 4 to get here would give us y is negative 3/4 x. We established the fact that this has a transverse axis that is vertical. So as we draw this, we've got to start at the vertex and head towards the asymptotes. So the graph of the hyperbola will look like this. Start at the vertex, head towards the asymptotes. That's about the best we can do with a hand-drawn graph. Let me go ahead and do a similar thing on Desmos. So I'll pull that up, and then we'll see what we have here. Again, our center is 0, 0. We see that we have two vertices, one at 0, 3 and one at 0, negative 3. We drew that little box. Let me quickly draw that little box for you if I can. Y equals 3 from negative 4 to 4. So there's the top part of that box. And then we'll go to y equals negative 3 from negative 4 to 4. Again, y 4 to 4, starting at the center, span in x is 4, so 4 left, 4 right. The span in y is 3, so we're going to have x equals 4, x equals negative 4. Ranging from negative 3 to 3. And that's the box that we need once we get it done here. we have our vertices. Let's label those as V so we don't lose sight of what those are. So the hyperbola has to start there. Now we've got to draw our asymptotes again, up 3 over 4. So y equals 3/4 x. Slope is 3/4, and y equals negative 3/4 x. Those are our two asymptotes. And from this, now we can draw our graph. Remember, starting at the vertex and then heading towards the asymptotes. We know the vertices are on the y-axis because the transverse axis is vertical. Why did we know that? How did we know that? Because y comes first. Y comes first, that tells me the transverse axis is vertical. Because if you look at the box that we had, if I switch the order, right? If I had x squared over 16 minus y squared over 9, the vertices would be here on the x-axis and you would graph it that way. So at this point, I think I'm probably ready to go ahead and draw the graph. Y squared over 9 minus x squared over 16 equals 1. And that should look good. So there we go. Now, the next thing I want to do is I want to prove that 3, 3.75 is on the hyperbola. So let's see, 3.75, is it? Let's click, get close to there if we can. And Desmos is telling me indeed it is. Desmos is telling me that 3.75 is on the graph. So what I'd like to do is I want to think about the definition of a hyperbola. Everything is based on the distance from the point on the hyperbola to the focus. I don't have the focus yet. I guess I need to do that next. So let's go ahead and find the foci. So let's jump back to find the equation of our foci. So I've got y squared over 9 minus x squared over 16 is 1. Y squared over 9 minus x squared over 16 is 1. Our goal is to find the foci. So our rule here is going to be c squared is a squared plus b squared. So remember, this is our general form. Y squared over a squared minus x squared over b squared is 1. So a squared is 9 and b squared is 16. So I get c squared is 9 plus 16. C squared is 25. C is plus or minus 5. Now remember, the foci land on the transverse axis. Our center was 0, 0. So I've got to go up 5 to get a focus on the transverse axis, down 5 to get a focus. So that would be at 0, 5 and at 0, negative 5. Those are the two focuses, the two foci. So let's go ahead and put those on the graph. So we have the point 0, 5. And we have the point 0, negative 5. And those are both foci. So I'm interested in the distance. Here is a point we found on the graph, 3.75. We think it's on the graph. Maybe I'll go ahead and I'll actually prove that. But I want to find the distance from this point to that focus, from this point to that focus, and subtract. And I'm supposed to show that that difference is constant, that if I pick any points on the graph, that distance will always be the same. So first of all, let me quickly prove that 3.75 is actually on the hyperbola. Prove 3.75 is on the hyperbola. What was the equation of the hyperbola? Y squared over 9 minus x squared over 16 is 1. So plug 9 in for y. That'd have to be 3.7 squared over 9 minus 3 squared over 16. Does that equal 1? So let's go to the graphing calculator and do that. So in parentheses, 3.75 squared divided by 9 minus 3 squared divided by 16, and we hope that equals 1. And it does. So that proves that it's on the graph. Now, what do we want to do with that? Again, we want to show the distance from that point to this focus, the distance from this point to that focus. Point to focus, point to focus. And we want to subtract those. So the point is 3, 3.75. So I want the distance from 3, 3.75 to the first focus, which is at 0.5. And then I want the distance from that same point, 3.75 to the other focus down here, which is 0, -5. So how are we going to do that? Well, hopefully we know that the distance squared is the change in x squared plus the change in y squared. x2 minus x1 squared plus y2 minus y1 squared. 0 minus 3 squared plus 5 minus 3.75 squared. So what is that distance squared? Let's go to the calculator again. Zero minus 3 squared plus 5 minus 3.75 squared equals 10.5625. That was the distance squared. Okay, so the distance is the square root of that. The distance is the square root of 10.5625. And what does that give us? Square root 10.5625 gives me 3.25. So let's go back and look at our picture and see if that seems reasonable. So we're going to look at our graph again. From here to here, could you believe that's just a little bit more than 3? Well, from here to here is 3, so from there to there being a little bit more than 3 seems perfectly reasonable. But again, the difference of those two distances needs to be constant. So I'm going to go ahead and find the distance from this point on the graph to this focus next. Again, distance squared, change in x, x2 minus x1 squared, plus y2 minus y1 squared. 0 minus 3 squared again, was -5 minus 3.75 squared. So again, let's go to the graphing calculator to do that computation and see what we get. 0 minus 3 squared plus -5 minus 3.75 squared. And we get distance squared is 85.5625. So the distance is the square root of that. So what is the square root of that? What do we get? You get 9.25. So let's take a look at these two distances. The first distance from the point to the closer vertex was 3.25. Then the distance from that same point to the focus. From that point to the farther away focus was 9.25. So what is the difference of the distances? difference of distances is 6, right? 9.25 minus 3.25 equals 6. So now let's do the same thing with the point 0.03. And this shouldn't take very long at all. What is this point is on the graph, 0.3 is a vertex. So I want the distance from 0.3 to 0.5 and from 0.3 to 0, -5. Right, the vertex 0.3 is on the graph. So 0.3 to focus 0.5, right? You see 0.3, you see focus 0.5. What is that distance? I hope it's obvious. 0.3 to 0.5, distance equals 2. Then we go back and then we go to the other one. What is the distance from 0.3 to the focus 0, -5? Well, can we see it? There to there, 1, 2, 3, 4, 5, 6, 7, 8. That distance is 8. And notice the difference of those two distances. Remember, it was 6 previously. The difference of the distances, 8 minus 2 equals 6. That makes me happy. If I would choose any point on the graph, the difference of the distances would be 6. Would be the same. Excuse me. Pick any point, not necessarily 6, but they would be the same distance. That is the definition of a hyperbola. So if I picked this point over here, I found the distance from here to this focus, and from there to that focus. If I took the difference, the subtraction, the numbers would be the same. So there's our graph, there's our process. Center, span in Y, transverse axis is vertical, so the vertices are on the Y-axis. Span in X, draw the asymptotes. Gives us the equation. How do we get the foci? A squared plus B squared is C squared. C is the directed distance from the center.